idea is we wanted to support Rigo on Kubewarden. So this is why I called it one language, two frameworks. We have Rigo, and then we have two frameworks. One is Open Policy Agent, and the other is Gatekeeper. So let's go first with the language itself, with Rigo. What is it? So Rigo is a language that is kind of based on Datalog. Datalog itself is also based on Prolog. So as you can imagine, it's a weird Prolog. So it's a strange way, if you think about in general terms, like what we usually do with imperative programming languages, it's a strange way to provide some policies. But turns out that for writing policies, actually, it's a super nice language. And so why do we want to support it? And the reason why do we want to support it, the main one is that many people, as we thought, or we think there is many people outside that already brought some Rigo policies for their own customers, for their own usage, whatever. And of course, it doesn't really make a lot of sense for them to rewrite them on other languages, right? And even if we wanted to do that, there could be people that want to write Rigo as a first approach for this kind of policies, which makes sense, as I said before. And so let's see what is Rigo about. So Rigo basically has two important things. One is the input. That is basically what is the policy evaluating. Let's think about the JSON object. So Rigo gets into the input, the JSON object, and this is what it has to evaluate. And it also has another thing called data that is basically what we can provide to the policy in order to enrich the evaluation. This could be anything from certain settings for the policy itself to context about the Kubernetes cluster, for example, some list with all the namespaces that are there created, or other resources like if I don't know, a list of ingresses, a list of CRDs, a list of whatever. So Rigo policy can take two things. One is the input, that it has to take a decision on that, and then the data. And the Rigo program will provide an output. So the output will also be JSON based. So let's see an example here of a very simple Rigo. This is not OPA, this is not Gatekeeper. This is just a Rigo policy, and this is nice about Open Policy Agent. Let's say this Open Policy Agent uses Rigo, and Open Policy Agent is generic. It is not tied to Kubernetes at all. And so with Open Policy Agent, what you can do is write policies that are targeted to your program, and they can do any kind of thing that you wanted to evaluate. So there could be people within your company that can be writing these policies that are tying some parts of the system to some requirements or permissions, and then you write your program on other part. And what your program does is ask to these policies whether some resource is is good to go or not good to go for whatever reason. And so with Open Policy Agent, you can have a server. And basically what you can do in a regular deployment is you have your program that talks to OPA to request some stuff. And then you have a sidecar, and you talk to this sidecar in order to request it, whether the policies that are over there validate or not validate, or they don't validate the resource that I am asking for. And so then Kubernetes is just a special case of this, right? With Kubernetes, you basically have the admission webhooks. And basically what you do with this is Kubernetes is just one more user of this mechanism. So what you do is tie Kubernetes admission controller, and you register the OPA server as just a webhook to Kubernetes. So in this case, OPA will just go ahead and basically read the request, the admission review from Kubernetes, and provide an answer. So if we go back to Rigo, this is a very simple example where we have a default allow false on the top. This is like the rule that we are going to, on this case, this is the rule that we are going to talk to, or we are going to request, we are going to call. And so this is the entry point of this program. And then what we do here is by default, allow is false. And so the way Rigo works is that every statement inside every block is an AND. So we have two allow blocks over here. And so I don't know if you see my mouse, I don't guess so. But in any case, you have two blocks over there, two allow blocks. That is an OR. So you have either this block is true, or either this block is true, or both could be true. And so in this case, what you are going to do is to allow if the user is Bob and the method is get, Here, input could be anything. So in this case, what we are doing is providing a JSON object inside input, and our JSON object has one attribute called user, another attribute called method. Sorry. So what you can assume is that we are getting the head of the request and providing this over here. So, but this is just the JSON object. So we get the user. If the user is Bob and the method is get, we are going to allow this. Or we are going to allow this if the user is Alice. So if we have a delete method with Bob, this is not going to be allowed. If we have a delete method with Alice, this is going to be allowed because Alice is allowed in any case, regardless of the method. If there is no, if I get a Rafa user, this is going to be rejected. So because the default allow is false here. But as I said, this is not open. This is not a policy agent. This is just a Rigo program. And so let's look at an admission refresher. So we get the admission review object, and the admission review from Kubernetes has the request and has the response. And so this is the object that we get from Kubernetes. The API server, when we register a webhook, will send us this object in JSON format. And basically, this is what we have to unmarshal in order to evaluate. And so inside of the admission review, we have the admission request here. And you can see there are different attributes here, like name, namespace, object, old object. If you have a delete method or if you are updating an object, then you get an old object. So you can compare the new object with the old one. This is all filled in by the API server. Okay, so now if we go back to Open Policy Agent, we saw what Rigo is, and so we have Open Policy Agent. So the inputs on Open Policy are the whole admission review, because what I said before, Open Policy is not tied to Kubernetes at all. And so what Open Policy knows about is JSON that comes and JSON that goes out. And in this case, the input that the Open Policy Agent gets is the whole admission review. We just forward it to Kubernetes from Kubernetes. And so the data that it gets, it's the Kubernetes. You can have a Kubernetes key over here that has the cluster context. And this is not, again, from Open Policy Agent itself. I'm going to talk to you a little bit more about that. There is a sidecar called Kube Management. That is what people usually use with Open Policy Agent on Kubernetes. And Kube Management, this sidecar, basically feeds this information to the Open Policy Agent server and gets this information from the cluster. So you could have some resources being replicated from the cluster, like I want to replicate all namespaces, I want to replicate all pods or all ingresses, and they get replicated into the data object here. This is done by the Kube Management sidecar. And also the Kube Management sidecar allows you to do things like define policies into config maps, and then you have a number of config maps with a number of policies inside, and basically what it does is register that into the OPA server, and that's everything. And then you can have an arbitrary JSON that gets merged into this thing. So you have data, and you might have your own data settings, let's say, for your policy. So you might have a policy that can be configured with a data object that you provide. And the output from the policy is the whole admission review Kubernetes object. And so this is Open Policy Agent. And if we look at Gatekeeper, Gatekeeper is more tied to Kubernetes. Well, it's tied to Kubernetes. Is designed in order to be tied to Kubernetes. And what it does is slightly different. The input it gets is called the review object inside. And this the review object, despite being called review, is actually the admission request that is inside of the admission review object. This is kind of strange, but this is the way it is. And you also get the parameters. Gatekeeper allows you to provide parameters. Actually, you can even validate them. So you can create what they call a template, a constraint template. I'm going to talk about that in a second. And then you can provide parameters to an instance of the policy. And then you have also cluster context. On both cases, this is a to-do on our case. So you can, on Gatekeeper, you can say what is the inventory, what resources do you want replicated inside the policy. And so you can have cluster-wide resources or namespaces resources. And yeah, that's basically the cluster context on it. And then the output in this case with Gatekeeper is not the admission review object, as it was an open policy agent, is a list of violations. And if you get a message for each violation, in this case, there are 2 violations here. This would be a string. And so you get this list of violations because a single resource, a single request could have several violations. And if this list of violations is empty, then the request is accepted. Otherwise, it's rejected with this reason, with the list of messages. We actually concatenate them with a comma. So let's look at a demo. Let me try to share my screen. I don't know. This is the first time I share with this beast of Mac. So bear with me. Okay, I'm going to share my screen. That's it. Can you see my screen?
Yes.
Yes.
Okay. All right. So the queue management. This is what I was talking before. This is the sidecar that you can basically deploy along with the OPA server, and this is what allows you to load policies into OPA via Kubernetes, so via config map, and replicate Kubernetes objects. So this is what you get into the data object over there. And Gatekeeper is a little different. So you have a constraint template. This is a CRD that they define, Gatekeeper. And a constraint template basically has a number of targets. A number of targets is just a number of Rigo policies, Rigo file names. And so what you basically do with that, in this case, this is just one, you define this is the entry point. So the violation is the entry point for this policy. And so when you call to the entry point, you either get a violation or you either get no violations because this is the entry point. If everything over here is true, then you will get this reduced to true. Also, you will get the violation and the message over there will be returned. The message that you actually said over here on the last one, because you go one after the other with and then when you are, let's look at this one. So this one is about required labels. And so we have a violation here with a message. These parameters can be input or output. The thing is that since we are actually setting it here, this is actually an output. So this is the entry point violation, right? So we have a message, and the message right now is not an input, so it's going to be an output. So what are the labels that are provided? We get the input review object, the metadata of the object. It can be any kind of object, and we get the labels over there. So we got the list of provided labels. We also have the required labels. As we saw before, there is the input parameters in the case of Gatekeeper, and then we get the labels from there. This is a parameter of the actual policy. And so we read the labels from the parameters, that is basically this parameter, and then we have the required from the policy and the provided on the object. We compute the missing labels, that's required minus the provided, and if we have any missing label, then we are going to send message to this error, and message will be you must provide labels and the list of missing labels. And so if all one after the other is true, then message will be evaluated to this string, and then violation will be evaluated to true, which means that since you have one violation, it will be rejected with this message that you will be able to read from the other end. And the interesting part here also is that you can provide a number of targets. You might provide different Rigo policies, for example, here, or Rigo files, let's say. So you can also reuse code over there. So in this case, it's a very simple one. So what I did was to write an example over here. So we have a Gatekeeper one and an OPA one. And the Gatekeeper, let's look first of all at the make file. I think this is going to be interesting. So this is on the top one is Gatekeeper, OPA is on the bottom. And so if we go with OPA first, we see that we have, well, with OPA build, you can build the policy. The target is WASM. You provide the entry point. In this case, the entry point is policy main. So policy is the package, and main is the entry point. So is let's say the function. And so we use utility policy.rigo. This is what is going to be our entry point in this case. We output that to a target file, yes. And we also call to the actual policy. So let's look at the utility. So the utility, this is the entry point in this case for OPA. So if you remember, it's going to be policy/main, the entry point. And so this is our entry point. And so since this is OPA, we have to provide the full admission review object that Kubernetes has to understand. In this case, Kubewarden is what is going to unmarshal this response. And so this is our entry point. We provide this JSON object as the response. And the response is going to be this. And the response here, if we go over here, is going to be this object if all this here is true. And so here we are calling to admission deny, concatenating every admission deny that we get. And so the admission deny is coming from the top. And in this case, we are importing this from data. So from data is not only things that you can provide to the policy. If you compile, like, let me back to, so the next file here. So here, when we are building, we see this is one file that we provide, this Rigo file, and this is the other Rigo file that we provide. And so since we have two different packages, we open, this is the utility, and this is the policy. So we have this package admission that is our actual policy. And we have this, this other file that is the entry point. And so what we do on the entry point is to import data, which is the global object that we saw before, and then we import Kubernetes.admission. Kubernetes.admission is here, this package, our actual policy. And so what it does is to export, let's say, this function, this deny function. And what our entry point does on OPA is basically concatenating every admission.deny. And so what it does is basically concatenate everything that can evaluate to true here. And so we go here, and if reason is not empty, which means someone denied this, then allowed is going to be false because we are here. This is the object that is returned. This is the conditions by that this is going to be returned. So if reason is not empty, then we are saying allowed is false, and the status is the message that we got. And if in either case, if that's not the case, if here reason was empty, then we are going to return the UID that we got and allow this true. And the conditions here are no conditions. But if I remove the conditions, for some reason when saving, it appears. So yeah, whatever. It's not really needed, but yeah, it seems that the lint really wants conditions over there. And so this is our policy on OPA. Let's look at the policy on Gatekeeper so we can compare both. This is the same policy written in the OPA style, which is on the top, and the Gatekeeper style, which is on the bottom. So here we have our package and Kubernetes admission. We remember that this is not the entry point. Here, the entry point is on the utility. And so the utility is actually going to call to deny here. And so basically what we are doing here is we get the object namespace from the input.request.object.metadata.namespace. This is from the Kubernetes object. We basically get what is the list of allowed namespaces. And we basically say which ones are satisfied. And with satisfied, we go over the allowed namespaces. This is a parameter that you pass to the policy. And then allowed namespace is going to be true if the allowed namespace is going to be true if the object namespace is the namespace that we're evaluating right now in the loop, let's say. And so if there is no satisfied one, so our namespace is not in the list of allowed namespaces, then this is going to evaluate to true. And so we are going to print this message as our output. And this is going to be true, so we are going to get it denied. And on Gatekeeper is slightly different. We don't have an entry. Our entry point is this one directly. We don't really need to write, like in this case, the admission review. So this is why this is more tied to. This is why Gatekeeper is more tied to Kubernetes, because here with OPA we actually had to write admission review. Here, no, our entry point is just the violation list. We could have several of them because this is ORS if we write them like on this level, but we only have one. And so this is again an output. The message again is basically the same thing, and basically what we do is write the error back. As you can see, there are slightly differences. If I look at the OPA one, there are some slightly difference. Input request here is what we get from Kubernetes. Here we got input review. So some things need to be provided in a slightly different way. And also, if we look at data over here, we have data.allowed namespaces. This is the list that you provide to the policy. And here you have this is in a slightly different way. You have this in the input parameters. So yeah, that's like different. But yeah, in general, it works in the same way. So it's the same language. And so we can now go and basically I have the make file over here. So I can go ahead and make this one. Oops. So yes, this is the one accepting namespaces .wasm, and this is a wasm file. And on Gatekeeper, I can actually do the same thing. So it's basically the same thing. And if I go over there, file that is again a wasm binary module. This is being built with OPA. So it's just straightforward. And so now what I can do is run this with kwctl. I could also use a tool called Burigo, but kwctl run is now able to run this without any kind of issues. So with kwctl, you need to provide, because this is Rigo, but we don't know what kind of execution environment this is, whether it's OPA or Gatekeeper. So we have to provide this to kwctl run. Otherwise, it doesn't know what it needs to run. And so what we're going to do is to execute the step by step. So this is OPA. This is the request path. This is a request that I have for pod creation somewhere on my directory. And then we provide a settings JSON with an empty list of allowed namespaces. This is basically the parameters that we can pass to this policy in this case. And we are going to run the wasm file from OPA. And yeah, that's basically it. So this JSON object that you can see, the pod creation is just is being created on the namespace default. Let's look at that. There's no trick over there, so you just go there. So yeah, as you can see, the namespace is a default. The namespace creation over there is a default one. So we are now creating this with we are running the OPA one. And we want to run we have an empty list of allowed namespaces, so this is not allowed. This is rejected, as you can see. And then if we run the Gatekeeper one, so let's execute the Gatekeeper one here. We get the same answer, basically. And now what I can do is basically, let's put it here, like allowed namespaces, this is default. This is other, let's say. So now the error that we get is basically allowed is false again, but allowed namespaces are other. This is the error that the policy is writing back to us. And let's do the same with the OPA one, just for the sake of completion. And so, okay, this is the same error that we get. And now let's put default over there. So now default is on the list of allowed namespaces. Now this is allowed. With a OPA policy and with a Gatekeeper one, this is allowed as well, should be. Yeah, this is allowed again. This example is not very good because you can do that with RBAC alone, right? But the cool thing is that, this is just Rigo is working and you can provide anything you want. So this is just the example that we have, right? But you can have anything you want. And the cool thing is that it's working. So we can import any kind of policy written either for OPA or Gatekeeper, and it just works out of the box.